Hello and welcome to this video about arcs and angles of circles. In this video, we will explore the different parts of circles and how to use them to solve problems. Let's learn about arcs and angles of circles. When we look around us, after polygons, circles are the next most common shape that we are surrounded by in our environment. A circle is created by a 360-degree rotation. An arc of the circle is a part of the circle, and we identify arcs using points on the circle. Arc RS is the curved part of circle A, shown with the purple mark. Because arc RS is less than 180 degrees, we call this arc a minor arc. Arc RTS, or STR, is a major arc because it is greater than 180 degrees. We can find the measure of an arc using the fact that a circle is 360 degrees. If we know that the measure of arc RS is 130 degrees, we can find the measure of arc RTS by subtracting the measure of arc RS from 360 degrees, which would make the measure of arc RTS 230 degrees. Some important lines and segments associated with circles are chords, secants, and tangents. A chord is a line segment with either end touching the circle. Line segment LM is a chord on circle A. A secant line is similar to a chord, except it is a line that passes through 2 points on the circle instead of being a line segment. And a tangent line is a very special kind of line that only touches the circle at one point, called the point of tangency. Line PQ is a tangent, and point Q is the point of tangency. Knowing these vocabulary words related to circles is important in helping understand the circle theorems, which will help us solve problems. The radius of a circle is always perpendicular to the point of tangency. When two chords share a point on the circle, an inscribed angle is formed. In circle A, the chord RS and TS form the inscribed angle RST, which has its vertex on the circle. The arc that is formed by the legs of angle RST is called an intercepted arc. An angle that has the center of the circle as its vertex is naturally called a central angle. In circle C, angle MCN is a central angle, and arc MN is its intercepted arc. If we are given the measure of the inscribed angle or the intercepted arc, we will be able to find the measure of the other using a circle theorem that tells us that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Or we could say that the intercepted arc is twice as long as the inscribed angle. For example, in circle A, the measure of inscribed angle RST is given to us as 60 degrees. According to the inscribed angle theorem, the measure of arc RT is 60 degrees times 2, which is 120 degrees. Here's a special case of an inscribed angle. In circle A, inscribed angle PQR encompasses the diameter of the circle, line segment PR. Remember, the diameter of the circle divides the circle into 2 equal parts, called semicircles. A circle has a total of 360 degrees, so a semicircle has 180 degrees, or half the measure of a full circle. So this must mean that the intercepted arc of angle PQR is 180 degrees. If we use the inscribed angle theorem, we find out that angle PQR is 90 degrees because it is half the degree measure of the intercepted arc. Another important theorem we're going to take a look at is the central angle theorem. This theorem says that the measure of a central angle is equal to the measure of its intercepted arc. In circle C, since the measure of angle MCN, the central angle, is 110 degrees, then arc MN, its intercepted arc, is also 110 degrees. Let's take a look at an example problem. Line LM is tangent to circle T at point L. The measure of the central angle T is 35 degrees. What is the measure of angle LMT? Since we know that the sum of the interior angles of any triangle is 180 degrees, and that the radius is always perpendicular to the point of tangency, we know that angle TLM is 90 degrees. We can subtract 90 degrees plus 35 degrees from 180 degrees to find the measure of angle LMT. 180 minus 90 plus 35 equals 55. Therefore, the measure of angle LMT is 55 degrees. When secants intersect inside a circle, we can find the measure of the vertical angles created by using the measure of the arcs formed by the angles. It also works the other way around, if we need to find the measure of the arcs using the measure of the angles. Let's take a look at circle K. The secant lines DE and FG intersect at point H and create the arcs DF, FE, EG, and GD. Find the measure of any of the vertical angles. Notice that there are 2 sets, by adding together the measures of the intercepted arcs and dividing by 2. We will use the formulas measure of angle DHF equals 1/2 times arc DF plus arc GE, and the measure of angle FHE is equal to 1/2 times arc FE plus arc DG. Then we will use the vertical rule theorem to find the measure of angle EHG and the measure of angle GHD. Let's practice. The measure of arc GE is 170 degrees. Arc GD is 80 degrees. Arc DF is 60 degrees, and arc FE is 50 degrees. To find the measure of angle DHF, we will add the intercepted arcs DF and GE, then multiply by 1/2. Therefore, the measure of angle DHF is equal to 1/2 times 60 plus 170 degrees. So the measure of angle DHF is equal to 115 degrees. We will use the equation measure of angle FHE equals 1/2 times 50 plus 80 to find the measure of angle FHE, which is equal to 65 degrees. When two secant lines intersect outside the circle, we use a different method to find the measure of the angles. When this happens, you look at the two intercepted arcs created by the angle and subtract the measure of the smaller arc from the measure of the larger arc, then multiply by 1/2. We want to find the measure of angle WYU that is created by the intersection of secants WX and UV on circle Z. Angle WYU is intercepted by arcs XV and WU. The measure of arc XV is 30 degrees. The measure of arc WU is 80 degrees. To find the measure of angle WYU, we use the formula measure of the angle WYU equals 1/2 times arc WU minus arc XV. Therefore, the measure of angle WYU is equal to 1/2 times 80 degrees minus 30 degrees, which is equal to 25 degrees. A sector of a circle is a section of a circle between two radii. The red area in the diagram is an example of a sector. We can find the length of an arc if we are given the length of the radius and the measure of the central angle using the formula S equals pi r theta over 180 degrees, where S is the arc length, r is the length of the radius, and theta is the measure of the central angle. In circle A, the length of the radius is 5 centimeters, and the measure of angle MAN is 70 degrees. We want to find the length of arc MN. We will start by substituting what we have into the formula. S equals pi times 5 times 70 divided by 180 degrees. We will simplify to get S equals 6.11 centimeters, which is the length of arc MN. Thanks for watching this video, and happy studying!